For number 1, I'm going to try to do some intuitive explanation of K. K is the concentration of products over the concentration of reactants. And I'm going to invent this other thing, J, which is the amount of candy over the amount of healthy food. So if J is much greater than 1, that means that there's a lot of candy. And if J is much less than 1, then there is a lot of healthy food. Just to make sure we understand this, I'm going to invent some numbers here. How about if there are 1,000 pieces of candy and 1 piece of, I don't know, broccoli? Then that's 1,000. Or if you wish to have scientific notation. So there's that. And then if we have J is, let's say there's exactly the opposite. There's 1 piece of candy and 1,000 or 5,000 pieces of broccoli, I guess. Then that would be 2 times 10 to the negative something. 10 to the negative 4. So there's a small j, and there's a big J, and so big J, more candy, small j, more healthy food. And so, looking back at the example, K is big, much greater than 1, then the forward reaction is favored and essentially goes to completion. So that means forward reaction is favored means the products are favored, because chemical reactions are written from left to right, reactants to products. So forward reaction would be going to products, and yeah. And then K is much less than 1 is exactly the opposite. K is approximately equal to 1. So if K is about equal to 1, then of course neither. And then the one point that is important is that K, big K, which is very different than the little rate constant we were used to from last chapter. Big K has nothing to do with speed. Nothing at all to do with how fast the reaction happens, so that's why D is false.